Hi everyone, good day. This is Ma'am Janine and I am back for your second video for your math tutorial. Today we are talking about solving quadratic equation and rational algebraic equations. We are going to revisit your rational algebraic expressions or equations that you have tackled before in your grade 8 math, where we are going to transform them into quadratic equations and solve for it to get the value of x or its roots. Where examples like this, x over 3 plus 1 over x equals 19 over 12, which is a rational algebraic equation, can be transformed into this, 4x squared minus 19x plus 12 equal to 0, which is a quadratic equation where we can find the value of x or its roots. Before we move on with our main topic in this video, let's have first a quick recall on how to solve rational expression. For example, we have 1/3 plus 5 over 6. Now, to add these two fractions, we need to have the same denominator. As you can see, the first addend, the denominator is 3, and the second addend, the denominator is 6. So to make it the same, we have to find the least common denominator of the following expressions. To do that, we have to first find the multiples of the denominators, which is 3 and 6. So for 3, multiples is 3 and 6. For 6, the multiple is 6 and 12. Now we have to find the least common among these multiples, which is 6. Now this 6 will now be your LCD. LCD 6, that's what we are going to use as a denominator of these two addends. Now how are we going to make this 3 become 6? So first, for 5 over 6, we have no problem because the denominator of this fraction is already 6. So we just have to multiply 1 over 1, or it's the same. Now, for 1/3, to make the denominator 6, we have to multiply 2 over 2. So we will have 1 times 2 becomes 2, and 3 times 2 becomes 6, plus 5 over 6 times 1 over 1 gives you 5 over 6. Now, on this equation, we already have the same denominator. Therefore, we can add the numerators, 2 plus 5, and then copy the same denominators, which as the two fractions have, which is 6. So therefore, we can simplify this as 2 plus 5 gives you 7, and the denominator is 6. So therefore, the answer is 7 over 6. 1/3 plus 5 over 6 is equal to 7 over 6. Now let's have an example of solving rational algebraic expression. This time we are going to involve a variable x. Suppose I have example 3 over x plus x over 10. Now we cannot add these two fractions because they do not have the same denominators. To make the denominators alike or the same, we have to find also the LCD. Now the LCD is generally found by multiplying all the denominators as long as they are relatively prime. Now for this case, x and 10 are relatively prime because no other factors will divide the expression except 1. Therefore, your LCD is 10x. Now, this 10x will be the new denominator of these two fractions. Now, to have the new denominator, which is 10x, we have to multiply 10 over 10 to 3 over x. By doing that, we will have to multiply x by 10, we'll get the new denominator, which is 10x. On the other addend, we have to multiply x over x because 10 times x gives also 10x. So we can simplify it as this. 3 times 10 over 10x plus x times x. Now, as you can see on this part of the solution, we have the same denominator, which is 10x. Now, we have to just simplify the numerators. 3 times 10 gives you 30, and x times x gives you x squared. Now, since the two fractions have the same denominator, we can simplify it as 30 plus x squared. Or we can make it in standard form, which is x squared plus 30 over 10x. Now, this becomes a quadratic equation from a rational algebraic expression to a quadratic equation. Now let's consider another example of solving rational algebraic expression. Suppose we have 5 over x minus x plus 4 over 3. Just like the drill, we have to find the LCD. Now for the LCD, x and 3 are relatively prime, so we just have to multiply the two, x times 3. Now the LCD will be 3x. Now this will be the new denominator of our expression. Now to make the expression have the new denominator 3x, we have to multiply 3 over 3 to 5 over x and multiply x over x to x plus 4 over 3. Now, multiplying that, we'll have 3 times 5 over 3x, x times x, quantity of x plus 4. We have the same denominator now, which is 3x. Why? Because x times 3 gives you 3x, and 3 times x gives you 3x. Now, for our next solution, we have to simply multiply 3 times 5. We can just copy that. And then for this particular expression, we have to distribute x to quantity x plus 4. X times x gives you x squared, and x times 4 gives you 4x. Now pay attention to this next solution. 3 times 5 gives you 15. I guess we have no problem with that. But what happens to these signs? Our negative here or our subtraction here, we have to distribute this sign to the numerator. Negative times x squared gives you minus x squared. And negative of positive 4x, that's why we have here minus 4x. Okay? So, 5 over x minus x plus 4 over 3 is now a quadratic expression, which is 15 minus x squared minus 4x over 3x. Now let's consider another example of rational algebraic expression. This is 3 over x plus 2 plus x over 7. Now for this particular example, we still do not have the same denominator. So we have to find the LCD. Since x plus 2 and 7 are relatively prime, we have to multiply this 2. Okay? So in this case, we just have to distribute 7 to the binomial x plus 2. So we have to multiply 7 by x and 7 by 4. That's why we'll have 7x plus 14. 7 times x is 7x, and 7 times 2 is 14. Now, this LCD will now be the new denominator of our fractions. To make that, we have to multiply 7 over 7 to x over x plus 2 and x plus 2 to x over 7. Now, applying that, the LCD now is 7x plus 14 for both of the addends. 3 times 7 and x plus the quantity of x plus 2. Now, if we're going to simplify that, 3 times 7 gives you 21. And x times quantity of x plus 2, we have to distribute x. X times x gives you x squared. And x times 2 gives you 2x. Now, as you can see on this part of the solution, we have the same denominator, which is the LCD. Now, we are ready to combine these numerators. That will give us 21 plus x squared plus 2x over 7x plus 14. Now, this expression now becomes a quadratic expression. Okay, so for learning task 1, what you have to do is to find the least common denominators of each expression. Now, I have said you just have to follow the examples before to get the least common denominators of these 4. Don't forget to write it in a one whole sheet of paper and submit it on the next retrieval. Now, let's solve quadratic equation and rational algebraic equations. Now, let's solve equation transformable into quadratic equation. Suppose I have 6 over x plus x minus 3 over 4 is equal to 2. On this particular example, we have to first concentrate on the left side of the equation, which is 6 over x plus x minus 3 over 4. Now, to simplify this part of the equation, we have to have the same denominator. Now, as we have discussed previously in this video, to get the same denominator, we have to first find the LCD. Since x and 4 are relatively prime, we just have to multiply these two to get the LCD, which is 4x. Now, to use that 4x, we have to multiply 4 times 6 in the numerator, and for the other addends, we have to multiply x times the quantity of x minus 3 to use the denominator 4x. Now, if we apply multiplication on the numerator, we'll have 4 times 6 gives you 24. Distribute x to x minus 3. So, x times x gives you x squared, and x times negative 3 is negative 3x. That's all over 4x, which is the same denominator for the two addends, equal to 2. So next, what happens here is the whole number 2 on the right side of the equation becomes a fraction, which is 2 over 1. Why did we do this? Because it would be easy to apply proportionality or cross multiplication on this equation if both of the equations, a part of the equation is a fraction. So how do we do cross multiplication? So we simply multiply 24 plus x squared minus 3x by 1. That's why we have 1 times 24 plus x squared minus 3. Now, on the other side of the equation will be the multiplication of 2 and 4x. So, 2 times 4x on the other side of the equation when we apply cross multiplication. Alright, now let's apply multiplication on each side of the equation. 1 times 24 plus x squared minus 3x is simply 24 plus x squared minus 3x. While 2 times 4x is equal to 8x. Now, next is to transpose 8x on the other side of the equation. This becomes x squared minus 3x minus 8x because positive 8x becomes negative if we transpose it on the other side, plus 24 equal to 0. Now simplify that. We'll have x squared plus minus 11x plus 24 equal to 0, which is a little bit more familiar to us this is a quadratic equation. Now to solve this, there are several ways to solve quadratic equation. As we can remember from the past week's lesson, we can use quadratic formula, completing the square, extracting the roots, and factoring. But let's use quadratic formula. So if we apply the quadratic formula, find the values of a, b, and c, and substitute it on the formula, we'll have negative of negative 11, positive and negative square root of negative 11 squared minus 4 times 1 times 24 over 2 times 1. So next solution gives us 11 positive and negative square root of 121 because negative 11 squared is 121, positive. And 4 times 1 times 24 gives you 96. And over 2, of course, is from 2 times 1. We simplify it as 11 positive and negative of square root of 25 over 2. Extracting the square root or applying the square root, we'll have 11 plus or minus of 5 over 2. Now, at this point, we are ready to get the two values of x, 11 plus 5 over 2, and 11 minus 5 over 2. Let's concentrate on the first root. 11 plus 5 is 16 over 2, or we simply have x is equal to 8. Now, on the other value of x, 11 minus 5 gives you 6 over 2, or we simply have value of x as 3. So 8 and 3 now are the roots or the solution for the quadratic equation x squared minus 11x plus 24 equal to 0. Now, if you opt to have another solution, we can also use factoring. So if you factor x squared minus 11x plus 24, just get the factors of 24 that will add up to negative 11, and that's negative 8 and negative 3. Now, we have to apply the zero property. X minus 8 equal to 0, and x minus 3 is equal to 0. So for the first value of x, we still have x is equal to 8 and x is equal to 3, which is the same as using the quadratic formula or using factoring. So again, the solution for 6 minus 6 over x plus x minus 3 over 4 equal to 2 is 8 and 3. Now, let's have another example of equation transformable into quadratic equation and solve it by finding the values of x. Now, I have here x minus x over 3 plus 1 over x plus 19 over 12. Now, again, we are going to concentrate on the left side of the equation, x over 3 plus 1 over x. We have to find the LCD because we do not have the same denominator, but it's easy because 3 and x are relatively prime, so we just have to multiply these two to have the LCD. LCD now will be 3x. Now, to use the denominator 3x, we have to multiply x by x and 1 times 3. Now, applying multiplication, x times x gives you x squared, and 3 times 1 gives you 3. Now, at this point, since our right side of the equation is already a fraction, no need to do what we did on the first example. We are ready to cross multiply. Cross multiplication, x squared times 3, x squared plus 3, we have to multiply by 12. That's why we have 12 times x squared plus 3. Cross multiplication again, 19 times 3x. That's why we have on this side 19 times 3x. Now we have to distribute 12 to x squared and multiply also 12 to 3. That's why we have 12x squared from 12 times x squared and 36 from 12 times 3. Now for the other side of the equation, 19 times 3x gives you 57x. Now we have to just transpose 57x on the other side of the equation. It becomes negative 57x. Now again, this is quite familiar to us. This is the quadratic equation. But this particular quadratic equation has, we can still simplify this because all of the terms in our quadratic equation have the same common factor, which is 3. So if we divide 3 on all of the part of the equation, will be simplified as 4x squared minus 19x plus 12. 12x squared divided by 3 gives you 4x. Negative 57x divided by 3 gives you 19x. And 36 divided by 3 gives you 12, equal to 0. Now, this simplified quadratic equation is what we are going to use so that it will not be a greater number when we do the or use the quadratic formula. It would be easy for us to calculate when we are going to substitute the values of a, b, and c as for negative 19 and 12 respectively. So negative times negative 19, positive and negative, square root of negative 19 squared minus 4 times 12 over 2 times 4. Simplify that, we'll have positive 19 because negative times negatives gives you positive. And then a positive negative of square root of 361 minus 192 over 8. Applying subtraction here, we'll have 19, a positive of negative of square root of 169 over 8. And applying the square root here, that is simplified as 13. So 19 positive and negative or plus minus 13 over 8. Now we are ready to get the two values of x or the roots. 19 plus 13 over 8. And for the negative one, 19 minus 13 over 8. So 19 plus 13 is 32 over 8, or simplified as 4. 32 divided by 8 is 4. So our first value of x is 4. While for 19 minus 13 over 8 is 6 over 8. Or simplify this fraction to its lowest form, we'll have 3 over 4. Now, if you are a little bit good in factoring, we can also use factoring. On this side of the equation, on this side of the solution, we can see factoring. Factors of 4x squared minus 19x plus 12 is 4x minus 3 and x minus 4. And use zero property. 4x minus 3 is equal to 0 and x minus 4 is equal to 0. You'll have the same value for x, which is 3/4 and 4. Therefore, the solution of x over 3 plus 1 over x equal to 19 over 12 is 4 over 3 and 3 over 4 and 4. Now, just like the two examples before, you are now ready to answer learning task 3, but part A only. Okay? Again, we are going to do learning task 3 for this week, but part A only. You're going to answer the 3 items, apply what we have discussed on the 2 examples before in this video, transform this rational equation into a quadratic equation, and solve for the values of x or the roots by applying the different methods that we have discussed in the previous weeks. You can do quadratic formula, completing the square, factoring, extracting the roots if possible, completing the square if possible, whichever method you are comfortable with, for as long as you're going to write it in a one whole sheet of paper with complete solution. Okay, so items 1, 2, and 3 for learning task A only. Again, so for this week, let's have a quick recap. There are 2 outputs that you are going to do. One is learning task 1, items 1 to 4, and learning task section A only, items 1 to 3. Write it in a one whole sheet of paper with your complete solution. Okay? So that is it for our math tutorial video for this week. Don't forget to like our official Facebook page, DepEd Tayo Luis Y. Ferrer Jr. West National High School, General Trias City, for the latest updates on our school. And of course, to get more instructional videos from your dear teachers, don't forget to subscribe to our official YouTube channel, DepEd Tayo West High. Click that subscribe button, notification bell, and like this video if you learned a lot. See you again on the next one. Bye!